Welcome to our webinar number 25, the Reclaim Network Plus webinar series. My name is Dr. Jannis Wenk. Today I'm here on behalf of Professor Prashant Kumar, who is on a research trip. So I will host the webinar today. Okay, next slide, please. Yeah, so just a brief introduction, Reclaim Network. So we are a group of different PIs. So Professor Prashant Kumar, I mentioned already, he can't be here today. Then there's also Dr. Nerea Calvillo in the network from the University of Warwick, Dr. Thomas Kjelsen of the University of Bath, Professor Lawrence Jones from UK Centre of Ecology and Hydrology, and Professor Shelak Malham from Bangor University. And our network manager, who is also in the webinar today, is Mark Simmons, and Charlotte Leden and Cisse Dibel are project officers, and Charlotte is also here. Next slide. And our network consists of 605 members already. They are here we can see here from different areas such as public health and well-being, planning and governance, also groups that are interested in trees and other types of green infrastructure. The majority of members are from academia research, 63%. We have also student members and NGO members, consultancy services, local government, city officials, and business members as well, and also from local community groups. And similar here, we see on the right-hand side, the interest areas are quite widely spread out. And then the webinar series runs now until February 2025. It is every first Wednesday every month between 12:30 and 1:30, and we have two speakers. And all the previous webinars are can be seen on the YouTube channel, and also today's seminar is recorded. And in case you are interested to become a webinar speaker yourself, you're very welcome to send us an email to info@reclaimnetwork.org, and then you can become also a webinar speaker. And now it's a pleasure to introduce our two seminar speakers of today. So I will first give an introduction for Professor Darren Woolf, and then later we have also Howard Gray, for whom I will then give a separate introduction. Professor Darren Woolf. Darren is chair of the CIBSE Building Simulations Group and a visiting professor in the Building Energy Research Group at Loughborough University. He founded and is chair of UKUEQ, which is a collaboration between CIBSE, Resilient Cities Group, and UK Wind Engineering Society. A key aim of that group is to generate and promote best available technologies and design practices leading to better understanding of and design for the urban environment in UK cities. Currently, there are 4 publication-focused activity streams covering urban vegetation, wind, thermal, comfort, and air quality. And with this, I would like to then open the floor for Darren, and we're looking forward towards your presentation. Questions can then be asked after the second speaker.
Thank you, Jannis, for the introduction. Can you see my presentation now and hear me?
Yes, we can.
Yes.
Fantastic. And thank you for the invite to this presentation. First of all, you may notice the change in title. I've had it the urban emergency. There's a reason for all that. Last week, we being UKUEQ, had our white papers called the Urban Emergency published, and also a overview article in the CIBSE Journal. A little bit more on that later, but now I can talk about the Urban Emergency. So our partnership is a collaboration between the CIBSE Resilient Cities Group and the UK Wind Engineering Society. We're a voluntary group focused on publications and events. We're hosted by CIBSE. We meet monthly online. We have been since September 22, and we've currently got over 20 organisations from industry and academia. And one of the central tenets of the group is that we're looking to reconnect the urban physics using integrated digital tools, and CFD is one of the main tools that we're looking at. So we mentioned we host events, and last year we had this programme at CIBSE's Build to Perform event at the Excel Centre. The sort of topics that we talked about were urban climate resilience, wind microclimate, outdoor thermal comfort, urban air quality, built form, and a gap between research and industry. And this November, we're looking to host another event, and this will be looking at a title, something like Urban Climate Responsiveness. So we have a number of other events that we're co-hosting during the course of this year. One is on bluff body aerodynamics and applications colloquium held at University of Birmingham in July, August, and this mini symposium is on simulated vegetated urban areas. The sorts of things that we're going to be talking about is wind, vegetation, tree drag coefficients, level of detail, effects of trees and parks, and also on turbulence as well, large eddy simulation of vegetated urban areas. The exact date and time is yet to be decided. The second mini symposium that we're co-hosting is part of the UK Conference on Wind Engineering. So this is WES 2024. We've got the day and time of our panel session on urban environmental quality agreed. We've got the panel members agreed. There'll be myself, Stefano, who's also the WES UK Wind Engineering Society chair, Steve from Air Quality Consultants, Julia from Ramboll, Marilena from University of Kent, and maybe one or two more. And it's been organised by Martin from Imperial College. So I mentioned publications. We've got 4 on the go at the moment. The first, which I'm leading, is called CFD Modelling of Urban Vegetation Systems. So this was something that over a year ago we had the proposal accepted by CIBSE. It's a CIBSE technical memorandum, so it's a technical guidance. We're currently about at the point of 85% first draft. So this is something that definitely will be published later on this year. We have a second one looking at computational modelling of outdoor thermal comfort, being led by Rubina at Arup. A third one, you may be aware of the wind microclimate guidelines for the City of London. There's a take on that, taking it forward to all UK cities, led by Rob at Wirth Research. Then there's a modelling of outdoor air quality, led by Jenny at CIRC. We don't believe this is ready for pulling together into technical guidance at this point in time. We need some more research, some more development work. So this might be a white paper or position paper that we publish over the course of the next year. And there's a whole host of possible future publications, which could be covering things like urban heat island lighting, and following the publication of the modelling of urban vegetation systems, actually catching a bit more on the value as well. So we have a website, cibse.org/UKUEQ. And on that website, if you go to the pull down menus, you'll see a separate page on our white papers that I mentioned. These were published last week, and within the white papers we have special features on wind, thermal environment, air quality and acoustics. But on the main page of the website we do have a quick summary of what we are about as a group and the sorts of things that we're looking into. I mentioned the CIBSE Journal article that was published last week. So if you search CIBSE Journal Urban Emergency, you'll quickly get to this. So this was an overview article, and on the front of the article, they picked one of the images from the white papers, which catches quite nicely a schematic of urban physics. And urban physics defined as a science and engineering related to air, heat, light, sound, water, and surfaces. So again, from the UKUEQ webpage, main webpage, there's this poster that you can download, and this was presented at the CIBSE Technical Symposium last year. It tells us a little bit about us, some of the past activities, how to get involved, and you can also submit evidence via a link to a Google Doc as well. A little bit more on that later. So besides the urban physics I talked about there, the key part of that is the urban morphology and surface materiality, which drive local climate. This is an area that we need to understand a lot more about and understand its impact on all the various aspects of urban design and its impact on the urban environmental conditions, and whether we currently adopt one process for designing our buildings, whereas perhaps there could be alternative processes driving the design solutions if we thought about having different local climate zones. For example, does shading drive a solution, or wind drive a solution? So you may have noticed I pronounce our group UKUEQ and not UKUEQ or something like that. And the reason for that is I wanted to keep in mind ourselves that we are cooking up an urban soup. Typical working practices are quite siloed. Looking at wind, you may think about building massing, looking at air quality, transport, surface water, sustainable drainage systems, and various other things that we're looking at in isolation. But in reality, if we Venn diagram up all those ingredients to the urban soup, there are many interdependencies, and we could potentially improve our performance and increased value and better decision-making processes. And it's about understanding how these things work together. So we don't really know what the best recipe is. We have some targets that are individual targets, but the combined targets, the preferred taste, again, is something we're not that sure of. So the design language is quite limited at the moment. You may, for example, talk about sustainable drainage systems on a scheme, or green roof. Are you talking about the metrics of blue-green roofs and their performance, and how they might, as a higher performing system, might improve the environment? Probably not. There's a whole wide, beyond the surfaces, beyond the building, external building envelope, there's a whole range of different areas that are listed there that we may again talk about, some of them in isolation, but certainly not talking about them together. So this is a simplistic view, a number of generalizations. I'm not talking about bursting the academic bubble, it's about moving the engineering wall. Currently at the moment, it's heavily siloed in academia, big focus on research papers. We can all pick out the variants to this, but when we look in the engineering circles, there's a massive focus on compliance. Are we meeting regs and planning requirements? There might be an awareness of some of the technical guidance. Is the academic side lacking relevance and slow? There might be perceptions along that line. Is the industrial side lacking robustness and poor applications? Again, there's evidence of this, and certainly perceptions of this. So we're actually in an urban emergency. What's our the optimized solution for emergency response? Moving the engineering wall. How do we get a lot more of the industrial engineering side in and the research papers, feeding easy access technical guidance, something that engineers actually pick up and read, and then have that focus beyond the minimum targets for compliance, but a performance-led design where we include in that the back checks on these minimum targets where those methods have been defined. Do we need a better funding model? I suggest we do, and more incentives for this to happen, but we are trying to respond to an emergency. And so to move that engineering wall, we need more academic standard research with practical industrial applications. Some advanced urban environmental questions. We quite often pick a climate, design a building, but what effect does our building and the surrounding buildings have on the urban environment around us? How are they, for example, generating cold downdrafts, impacting urban heat island effect at ground level? How does the combined wind and temperatures impact wind chill or our reputation and commercial success of a space on those colder days? How does wind and air quality combine together? There's a big focus on excessive windiness. I'm aware of one wind death case in 2011 up in Leeds, which has really focused our attentions on the excessive or high wind speeds. But what about those low wind speeds with the perhaps 4,000 air pollution attributed deaths in London per year due to air quality and flushing out that poor quality air? Then there's combining all these various aspects, shade, cooling, on outdoor and indoor together, and air quality all at the same time. Talking a lot more about surfaces, a bit of talk about albedo or reflectivity of surfaces, but also surface material selection. And then there's the not just about urban heat island discussions, but climate moderation. How do we increase our urban resilience due to climate moderation? So a little bit more on that. On a cold day, you could imagine that you've got unshaded hard surfaces about 0 degrees or less, and shaded or unshaded vegetated surfaces a bit warmer than that. On a hot summer's day, those vegetated surfaces might be about 30, 35 degrees if they're in the sun. But the unshaded hard surfaces might be 60 degrees or more. So I mentioned the urban heat island effect on the hot side. That is a lot of our focus is on that. But there is also an urban heat island effect on the cold side. And if we talk about climate moderation or all year urban moderation, climate moderation or mitigation, how are we positioning those designs? Cold side deaths are perhaps or attributed deaths an order of magnitude more than hot side deaths. So where is our annual temperature target? What's our best one? How can it be optimized for that? Quite often energy drives a lot of the thinking, but if we've got an optimum positioning of our annual temperature, then what is the impact on our annual energy demand? Perhaps that's a better way of thinking about it. So I mentioned this publication, CFD Modelling of Urban Vegetation Systems. On the wind resistance side, some of our findings that we're putting in there. We're looking at a volumetric drag model for trees, shrubs, bushes and hedges. It's different to a classic drag coefficient approach, which is more like a thin surface approach coming out of experimentation. Model resolution and how that relates to capture of velocity decay. Again, this is horizontal and vertical winds due to downdrafts, how we understand that dual approach. And then potentially this could have a big impact on computational wind engineering models and BATNIC good practice. That's where we're designing our publications, best available technology not exceeding excessive costs, and how that we do that in terms of geometry as well. On the evapotranspiration rate and central latent heat gains, it's a very complex system, urban vegetation systems. We're looking for a compromise application for industrial usage. You might have over 200 trees in a master plan model. There's a top-down approach where you've got the water demand specified, a bottom-up approach where you're picking plant types and thinking about water stress. It includes the total absorbed radiation, which determines the sensible and latent heat gains. And when this compromise model, there is also, we think, typically that vegetation generates cooling. But if you've got high levels of radiation, it's water stress, it could actually become a heat source beyond the shading to the nearby surfaces. And this model is applicable in sunlit conditions. So some questions for this network. We will, in the coming months, be publishing this technical manual. There's an opportunity to expose raw data. We need raw data on all those various elements and listed there and by species and season. Some of those data inputs are leaf area index and density, summer and winter, evapotranspiration rates, extinction coefficients, water stress to martel resistance relationships. If you can, or you have that available, that data available, please do either let us know directly or via the poster evidence where you can submit that by the end of July. Summary and conclusions. So we're in an urban emergency. Our cities are at increased risk from climate and air quality, the emergency that we're needing to deal with and respond to. At times, the environmental quality is extremely poor, leading to significant health risks and reduced productivity. This leads to higher costs for urban living. That's a key phrase there. So how do we move from that first cost mentality on our developments to much, much wider co-benefits and understand that the cost of urban living and put that into our deliberations. Then there's increasing urban climate and air quality resilience as a priority, a much greater priority. How we do that to achieve those co-benefits, thinking about short, medium, long term. So this is about moving from the huge efforts on climate change mitigation to additional efforts on climate change adaptation, putting it on a similar footing. I mentioned the urban soup, and obviously it's a complex, multi-factored ecosystem. There's many, many interdependencies that we need to work through, but there are many opportunities for better designs and innovations with urban physics at the core. It's not about significant skills developments. It's about much, much more to do with better working practices. And we need within those working practices to find the right balance using a much more holistic approach. So there's many challenges, many different issues and solutions, and what we do, we need to start doing that now at scale and at pace. And within UKUEQ, we're working to understand and provide better guidance on this. So that concludes my presentation.
Perfect, Darren. Spot on time. Thank you so much. We will now just move on to our second speaker, Helen Gray. I will just introduce Howard. Howard is a passionate advocate for urban green investment. He has worked in this industry for over 30 years, persuading stakeholders of the importance of parity between green, blue, and gray infrastructure, and also campaigning for better holistic design. Howard's drive for the creation of healthy urban spaces in harmony with nature is impressive and leaves you wanting to get involved and change the world for the better. So yeah, that my introduction to Howard. So please go ahead and share your screen.
Sorry, hang on, just trying to sort this one out.
Yeah, take your time. In the meantime, please, if you have questions to Darren, then please write them down, and we will ask questions by the end then.
Has that screen come up now, Jannis?
Yes, it's there.
Brilliant. Thank you very much indeed. Thank you for the opportunity to present today. As you've already heard, I'm not a tree hugger, but I'm an enthusiastic advocate for green infrastructure in our urban areas. As we've been hearing from Darren, we are in times of a national and international emergency when we're looking at our urban situations with the many challenges that we have. But what I would like to talk about today is that how we can guarantee our green infrastructure within our urban areas, not leave it to chance, not end up planting poorly so that we end up with temporary infrastructure, but looking for something that outlives ourselves. And it's very important that when we're thinking about our green infrastructure, that we're looking to provide resilient landscapes for future generations. And the way the GreenBlue Urban has worked for the last 30 years is by using waste material that's generated from the plastics industry to provide assistance particularly to trees, but to green infrastructure to enable it to establish in what is a pretty hostile situation. It's important to realise that many of our challenges that we face in our urban environments are actually caused by ourselves. We have actually caused these issues, and we have to really start thinking about how we can wind the clock back and return to a way that is looking at things in a far more holistic way, where we get this balance between our green and our blue and our grey that actually works for all of us in every circumstance. As Darren has been saying, we are facing some severe crises. Our planet is warmer now than it has been for the last 800,000 years. That's a pretty long period of time that we're experiencing a massive difference over. We're also suffering a net loss every year of our canopy cover worldwide. Often been spoken about that the Amazon rainforest is the lungs of the world, but we actually start thinking a bit closer to home, that whether it is actually, as on this slide, whether we're just losing our forests to create more grazing space, or whether it's even just part of a forestry initiative, we must consider how much we're losing in terms of canopy. We also have to think of our marine life. What we're seeing is a huge amount of plastic isn't actually efficiently reused or recycled. It ends up in our oceans and our seas. And this is causing us massive amount of problem with our marine wildlife. So what are these challenges we look at? Well, our increasing population and particularly urbanization is giving us a myriad issues. And it doesn't matter whether we're talking about our infrastructure, whether it's our health, whether it's our transport, whether it's our drainage, or whether it's our education. These urbanization is causing us massive issues with our infrastructure. But what we need to start thinking about is what are the challenges, and therefore what are the answers, and how can we guarantee that what we're planning to do will actually work? Well, GreenBlue Urban has this mission statement: nature in the built environment. That means that we're constantly keeping one eye on the science as well as actually on the practical side of installing green infrastructure in hostile areas. And this makes GreenBlue Urban pretty unique in the fact of the amount it does in terms of research to justify scientifically every solution that it provides. GreenBlue Urban looks to provide solutions that work in difficult circumstances, whether that's tree planting, whether that is sustainable drainage systems, whether this is solutions that help us with our urban heat island effect. What we're looking to do is make sure that we guarantee these for the life of the plant. So when we're looking at urban trees, which is where GreenBlue Urban started over 30 years ago, we start seeing some massive benefits in terms of mature, healthy growing trees. Whether we're looking at property values, whether we're looking at heat island effect, whether we're looking at air pollution, whether we're looking at actual amounts we'll pay in terms of retail. There's some huge benefits that accrue from these trees, but only if they live. Too often we see poor planting, which dooms these poor trees to an early death and means that we're not getting the benefits we're looking for. So GreenBlue Urban have constantly worked at making sure that every tree we plant has the ability to hit species potential wherever it is being planted. And we do this by using these waste materials, waste plastics, and 100% recycle them and use them to make solutions that really work. In fact, that are guaranteed to work, and I'll touch on this later. So made in the UK from 100% recycled UK material. And this is down near Hastings, where we have our manufacturing plant to make these products that are able to help us guarantee the life of the tree. So we have our own recycling machinery, so we can actually chip up any waste material and then use that back into the manufacturing process. And as we use very high quality recycled polypropylene, this means this can be done pretty much an infinite amount of times without losing structural strength. So the root space arbor system solution is really a soil cell that's able to withstand heavy loads going underneath trafficked areas to provide the tree the ideal optimum rooting environment, really recreating the forest floor environment underneath a paved surface. And this is really important because what we're doing is we're creating this soil, keeping the soil healthy, keeping it uncompacted, keeping it aerated, so the tree is able to attain this maturity that really starts bringing us the benefit. A mature tree brings us so many more benefits than a small struggling one, that it's important that we are planting not more trees, but we're planting trees that will attain greater age and greater size. And the soil cell system comes complete with legs and infill panels and aeration lids, and able to take loads of up to 40 tons a square metre. And these are available from stock, available very, very quickly. Now, one of the important things is we're beginning to look at the actual value of trees along our highways. And this is really interesting because what we find is there's a number of different benefits that perhaps are more than we originally thought. Whether we're talking about even something like protecting our asphalt, we find that local authorities are realizing that these hotter summers that we're having are causing road surfaces to break up quicker than they used to. And this is really interesting. A highways engineer told me recently that many of the potholes we're struggling with are actually caused by the cracks that occur in the summer with the extreme heat, which are then forced apart by the rain in the autumn and winter. So we're seeing some quite significant differences. Even things in noise pollution can be massively mitigated again by green infrastructure. That's not just trees, living walls, green roofs. These are all helping that noise reduction that we're looking for. So GreenBlue Urban have published this book, which is free to download from the greenblue.com resources tab on our website, which is looking into urban trees, highways and utilities, how we can work around all these challenges that we find underneath the ground to actually make sure that we make enough room for our green infrastructure to grow to maturity. This is an interesting project that we're still working on in Glasgow. Sauchiehall Street is one of the main feeder streets that runs in from the west end of Glasgow into the city centre. And Glasgow City Council commissioned the first phase of this project, which goes back 6 years ago, where we planted trees down what was basically the middle of the street, separating cyclists and pedestrians from the motorists. And this has made a massive difference. It's really changed the whole area. Never had trees in those streets before, but it's really changed the character of the street. It's made it a far more family-friendly place. Cycling is up by 80%. And these next phase, which we're just installing at the moment, this is taking highway runoff as well. So this is really beginning to bring those green, those blue, those grey elements together in a really interesting and innovative way within the city centre. As we can see, the first phase, we've got some really mature trees now that are growing very, very fast indeed, and bringing us those benefits within 5 years of planting. I mentioned before that we can actually guarantee trees, and this is the first in the world company able to do that. We can guarantee a tree to its full health in up to 15 years. If the tree fails for any reason that's to do with its rooting system, then we will pay for that tree to be replaced completely, including all capital and construction works. Now, this shows us a sign of our confidence in our system, because what we say is that trees don't die. On the whole, they are killed. And so what we must do is by planning for the tree, providing for the tree, and protecting that tree, we're giving that tree the very best chance of attaining that species potential. Another interesting project that we worked on is in Manchester, in St. Peter's Square, which is one of the most heavily urbanised areas we've ever worked in. We've got trams running right through it, we've got buses, we've got dust carts and emergency vehicles, and yet we've got some huge trees that have grown extremely well. These trees in under 10 years have hit their 40-year size expectation by giving them really good conditions and really helping them to establish quickly. I was up here on the hottest day of the year 3 years ago, and what we really found was that these trees are really giving us some massive heat island cooling effects, and people were moving from the shade of one tree to the other to take advantage of them. So it's possible to actually look into how these can work for us. The very first tree that we ever planted in soil cells is on the A2 in London, in Blackheath, and this tree went in back in 2001. So we've had over 20 years of tree health. The tree has to be clipped regularly, otherwise the buses clip it. But the interesting thing is that though that tree now is a massive tree, there's no movement to paving. We've designed a system that means that tree can coexist with hard paving and with the utilities without causing a problem. And another one in London that's probably quite many of you will be quite used to seeing is the row of trees outside St. Paul's Cathedral. Fantastic large London plane trees, and yet these are iconic. Planted between 2005 and 2008, these trees are in the full GreenBlue Urban Arbour system with the soil cells, with irrigation, aeration, underground guying, and these trees have come to dominate the whole of the square. So in conclusion, we'd like to say that it's possible to get mature canopies, mature trees into our area, into our urban areas to help with these challenges that we face, but we must plan for them, we must provide for them, and if we're going to have them long term, we must protect them. We must carefully think about what we're trying to achieve, and if necessary, plant less trees, but plant the ones we plant better to achieve this green, blue and grey, using our green infrastructure to help deal with our stormwater efforts issues, help us with our efforts to combat our heat island, heat stress, and to really enhance our grey infrastructure, that we create places where we want to live, work and play, and that will be resilient for future generations. Thank you very much indeed.
Thank you, Howard, very much for this very interesting presentation. I think now we are open for questions, and I think also Mark has mentioned that you can also post your questions in the chat if you do not want to ask them live. Nerea, are you actually going to take over for the questions?
Yes, thank you, Jannis.
Okay, great. So then I will please, Nerea, go ahead. Then I will turn off my microphone then.
Okay, there's a question from Yash Ramani. Hi, Howard. I want to know how much time does it take for those trees to grow?
It's a great question. Thank you very much indeed, Ash. It depends on a number of different factors, particularly the tree species, which certain trees are faster growing than others. But very interestingly, when we provide a proper green, blue, grey infrastructure, so we're using the trees to take runoff water off hard surfaces, we get probably approximately twice the speed of growth. By passing water through a growing medium into which plants are growing really forces those trees to grow a lot faster. So what we are finding is that it's very, very effective, not only in stormwater capture, but also in helping those trees to grow. What we would normally reckon is that a tree that is planted at what we call a semi-mature size, maybe 3 meters tall, maybe a little bit taller than that, could easily attain 6 to 7 meters within 5 years and really fill out as well. So what we see is a properly planted tree will establish very, very quickly and then continue to grow until it reaches the limit of its soil volume available to it, at which point then the growth starts slowing off and it starts plateauing. Many of the trees that we see in our streets that are just planted in a small little pit where they've just taken up maybe a paving stone and planted the tree becomes in effect pot bound, and it never actually becomes any bigger. So what we find is that often those trees struggle for their whole lifetime, but typically that would be less than 10 years.
Any more questions? Please share them in the Q&A function. Otherwise, I have a question for you both, actually. Thank you for your amazing presentations. As you've explained really well, we're in a climate crisis, and I was fascinated, Darren, when you mentioned that trees have all these benefits. However, they might have counter effects sometimes, depending on the environmental conditions. So now that we are seeing these intense droughts in the UK, but also maybe in other countries, the fact that the trees, because they're taking the water, might generate heat. Actually, how does that? Like, in which situations do you think that might happen, or do you think this is connected to larger climatic situations, or is more local in terms of how the tree is planted, or where it's planted, or what it has around? So could you please expand a little bit on the relationship between the capacity of trees to gain or release heat and what affects those? And this is a question for you both.
Yeah, absolutely, for Howard, on the practical planting types and how they actually perform in different situations. But from the physics perspective, I mentioned Martin van Rooij earlier, papers that he wrote a couple of years ago on really detailed models looking at net radiation coming in from the sun, direct diffuse, what's reflected, what's coming in from all the long wave radiation as well, and how that's absorbed into the leaves. And from that paper, if you look at the ICE, Institute of Civil Engineers, their trees and drought briefing sheet, you'll see quite quickly that's the sun and the wind that drives performance. So we need to understand a lot more about where a particular where is your, I won't say just trees, but where is your urban vegetation system? Where is it located? Is it on the roof? Is it on a shaded side of a wall? And then it's that at particular times, if it's shaded or unshaded, its performance will, in terms of how much it evapotranspirates, and the convective side as well, how much cooling or potentially heating, if there's not enough water in that system, if there's really high levels of radiation, solar radiation, then it may be a heat source. So like anything, it's about understanding the water side, as Howard was saying, alongside the vegetative side, the blue-green. That's the all-important. Otherwise, you may end up with a really poorly performing system that isn't doing what you want it to do. And the two need to be thought about together.
Yes, I would 100% support what Darren said. It can be in a situation, particularly where maybe a tree hasn't got enough soil volume, so there's not enough water available to the tree. That tree will then no longer evapotranspire because there's nothing for it to do so. So there will be no cooling effect from that tree. Particularly if it has a reflective type of leaf, it can end up reflecting that heat into other parts of the urban area. And that can be a real challenge because certain tree species which are designed or have evolved to cope with hot areas are very poor evapotranspirers actually themselves. They used to really reflect the heat away. So, for example, palm trees are not particularly effective in terms of cooling. Not that we struggle with too many of those in the UK, but it's something that we need to consider as to whether we're using effective species, whether we're giving them sufficient soil volume, and then whether they are reflecting heat. And what Darren says is so accurate. We can end up having the law of unintended consequences coming by actually not designing for it properly.
Thank you. I think this is an interesting but difficult to solve challenge in countries where the climate is much warmer, for example, and there's no water, literally, to water the trees, and then all the green infrastructures end up dying some years because they just can't survive. So, how would you? Do you think that a possible solution would be shading the trees so that they can keep more of the humidity, or what would be your suggestion for very hot climates where water is a very scarce resource and cannot be used for watering?
Well, we would say you have to choose a species that can cope with those conditions. That's the primary thought. The idea of shading trees seems to be a somewhat over the top because it's never going to be really self-sufficient. What we do find is that often, for example, trees that have evolved to live in the Middle East, where we do quite a lot of work, they've often developed very deep rooting systems where they can access water from deep in the ground. But they're often not very high evapotranspirers. So there's a lot of choices to be made, but it's very much specific to the climates that we're looking for. What we often do find in the Middle East is they do forced irrigation to try and encourage the trees to cool, to make sure, but that only works, of course, as long as the irrigation system's kept in good order, because otherwise it's a bit like a pub that doesn't open on a Friday evening. You have all sorts of trouble afterwards.
Can I just add one quick thing to that is, again, we tend to think of something like a tree in isolation. I earlier presented a slide on urban morphology and surface materiality. So if you think of it as part of a much wider system, and not only trying to have its greatest performance at a particularly static peak condition, but how does it perform throughout the course of the year? And also we are quite myopic with deciduous trees where the leaves aren't there in winter, and we may be designing without considering that in many aspects. So it is about species, it is about season, it is about that wider system performance.
And I'd just like to add to what Darren said in his presentation is, please take into account the wind factor when you're thinking about planting, because we get people who suddenly say, oh, well, we'll mitigate the wind speed around this tall building by planting trees all around it, without taking into account that massively increases your evapotranspirational rate, which means your trees will dry out a lot quicker. And if we use, for example, conifers, which don't evapotranspire so much, we then can end up with air pollution issues because of some of their oils which they kick out into the air. So it's really a matter of, as just couldn't agree more, what Darren says, we need to look at the whole urban area in context to make sure that we're really designing with not only what we are designing for, but what's also there and how everything will interact.
Thank you. I think there's a question being written right now in the chat.
Yeah, maybe in the meantime I can ask a question, Darren. I was quite intrigued by your slide, which shows the disintegration of academia and engineers. So, and then you basically moved the engineers more into the academics world. So, what is the most important research generally? What needs to be done, and how can we fix this disintegration?
Yeah, it's a bit of a disruptor, that slide, isn't it? But we are in an emergency situation, so the status quo, I believe, is not working at the moment. There's obviously small pockets of excellent research that is feeding through into industrial applications, but I would say that's more the exception than the norm. Others may disagree with that, but talked about funding mechanisms. I've seen research applications where the industrial side is not on a level pegging. It is prejudiced against industrial input into the research, whereas there could be some excellent input from industry that leads the research into a different direction, where you get far more practical industrial applications coming out there. So I think the system is in need of looking at again, and is it separate funding pots that are generated to do this, or is it a overhaul of the whole system? I don't know, but I do just know that the current system isn't really working well, and we need to perhaps look at how we can make it work a lot more better with that focus on the emergency and what we're trying to do.
Yeah, thank you. Yeah, I agree. It's from my own experience, I can also tell it takes a long time to get good industry academia contact. So there is a lot of upfront investment, specifically for academics, before you have these contacts, and then in the meantime you just continue research on your own quite often.
I mean, yeah, as we know in research, it's all about impact. There are routes to understanding impact. I question how good those routes are. Just getting citations, for example, we don't really know who's looking at what and how they're using it, and whether it's individual or whether it's something across a much wider organisation as an impact. So I think perhaps the perceptions of impact from academia aren't the same as reality. So yeah, I'm seeing some nodding. So
yeah, I agree.
Thank you. There are two questions, so let's see if we have time to respond to them both. The first one is from Tora Tenberg, and she asked about choice. They recently did a UK survey, which revealed that most people really welcome trees, another GBGI, but that they have very clear ideas of where to put them. So will there be ways of tapping into these? Councils aren't always sure that their plans will be welcomed, and they might hear more complaints than support. And of course, the general public doesn't have the insights that you talked about, but surely it matters that they want to be involved and that they welcome trees. So how do you deal with that tension between the public's needs and what the science needs?
I think it's a great question, and it's something that comes up a lot when in our discussions with local authorities. They have limited budgets, and where do they put them? There's a lot of work being done at ward level to look at which wards within local authority areas have the least tree cover. Often they're the more deprived areas, and then that would be probably where the focus would be for that planting. But interestingly, often when we plant in perhaps more exclusive areas, the residents take a lot of care for those trees themselves, and that really then helps the local authority in terms of maintenance costs. So it's a balance of getting it right and where it's going to make the most impact, where it's going to be the most effective. The second question is as to the issue of leaf fall and leaf litter, whether this is something that has to be borne in mind. And it's what we find is often the highways department who bear the brunt of those with their street cleansing operations. And it's something that that can be mitigated against by choosing tree species where the leaves rot away very quickly, or they're smaller leaves rather than large, huge, waxy leaves which can hang around for months. So it's really a matter of species choice, working with the local authority, working with the tree officers, and working with community groups. We've seen some really, really good schemes come out of just local people getting together and saying, we want this in our area.
Can I add to that?
Yeah, sure.
So, yeah, quite often you get these big PR campaigns, planting lots of trees in an urban park, and quite often the surrounding buildings, residential buildings around an urban park are high value. They would get the benefit within a few streets if the wind's blowing in the right direction, because wind moves cleaner air towards more polluted air, and can provide some of that cooling, but it's very, very limited. I believe there was a paper from the World Economic Forum that talked about pocket parks and how we start to think about local solutions. And if you start burying a pocket park in a street canyon, you're more interested in, is the windrows, which is all directions, leads to generation of wind flow in one direction down the street or the other direction down the street, just generally. And then you start to think about that localism of benefits. And then you potentially should be focusing on that to levelling up, near schools in poorer areas. Perhaps that would get much greater benefit and value for those investments. So that there is that whole thing about how we focus our investments, limited budgets, so that they do actually do what we want them to do.
Thank you both. I think our time is up, so I'm going to hand over to Jannis for
yes.
final talk.
Thank you. Okay, yeah, thank you, Nerea, for the Q&A, for leading the Q&A session. So I would also like to thank Darren and Howard again, so like a virtual clap from all of us, and then remind everyone that the meeting is recorded. And then I would also bring your attention to our next webinar, number 26, on the 3rd of July, which then will be by Joanne Matthews from Southend-on-Sea City Council on integrating nature-based solutions across the city of Southend, and from Dr. Karina Corrado-Perez from the University of East London. She will speak on greening the urban landscape, the potential of domestic garden for enhanced air quality and thermal comfort. And yeah, with that, again, I would like to close our today's webinars. Thank everyone for their attendance, and again, our two speakers for the great and informative presentations. And then if you would like to have more information from the Reclaim Network, we have a Facebook group. We are on X. We have also a website, and you can reach us via email.
Thank you.
Thank you, everyone.
Bye.
Goodbye.
Bye.
Have a
Thank
great
you.
afternoon.
Thank you
Bye-bye.
both. Bye-bye.
Bye.
Have a nice evening.